All right, and I'm going to go on mute and let you take it from here.
Cool. Can you see my screen? Maybe not. Yeah, can you see the presentation screen?
We can see the browser window. Not sure if you want it in presentation mode or not. Doesn't matter.
Yeah, I'm going to be toggling, so
Sounds
I'll
good.
just. We're all developers here. So yeah, this is just a little talk on FastAPI, kind of supporting details, Pydantic. We'll get into even some of the supporting details that support those things and kind of why FastAPI is special. But first, quick introduction. That's my cat you're hearing. So I'm Lyle. I've been doing Python for I don't know, over 10 years. I think I started on 2.2.3, but it had already been out a while, so things have progressed definitely since then. Write a lot of Python. I've always done it for work. I work at CBS doing streaming, Paramount Plus, that kind of thing. Use a lot of Python on the analytics side and on just general tooling and all throughout the business. But it's been a great language to learn, and can't recommend it enough if you're even looking at getting into the field of development. I really enjoy automation, obviously software engineering, and like kind of how can you move safe and fast, both from myself and from like a kind of engineering manager perspective, like how can my team move fast? And, as you grow, how do you just concentrate on business problems and let the kind of software do the hard work? Things are coming out all over the place these days, and everything's kind of converging on these safe, fast languages, no matter the language. So it is kind of cool. And we'll talk about stuff that is kind of new to Python. And if you're from like a typed language, you've been doing this for a decade. So this talk, like I said, it's about FastAPI and some kind of immediate tooling to support FastAPI. But it's generally about tooling to help you move fast. So I already kind of said this stuff. It's nothing really exciting here. So the problem I had and why I chose FastAPI, I both had a personal project that was starting to get traffic, and I was getting a lot of stuff at work. So our requirements were essentially, not a blazing fast API, but a reasonably fast API, something that's going to be easy to write with. I had all different skill levels on my team, so something that's approachable. And I got to start from a clean slate. CBS is a big company, but the streaming stuff's pretty new, so all our stuff tends to be brand new. So that was really my time to evaluate some things that are out there, some modern things, and like really try some new stuff. Whether they're the right fit or not. That's kind of how I came upon FastAPI. It was kind of the best on my kind of search for those criteria, and it was new. So there's more to the solution than just FastAPI, and we'll kind of dive into some of these as the talk goes through. There's FastAPI, which is the API server. There's Pydantic, which is the data serialization layer, right? Like how do you talk to the API, right? You send it maybe JSON, maybe you get JSON back, and Pydantic is essentially the data serialization layer of FastAPI. So we'll definitely talk about those a lot. I'll kind of skip over some of this. Linters is an important thing. So like, how do you write Python on a team and kind of solve kind of the issue of, hey, you write the same code this way and I write this way, who's right? A lot of y'all are probably used to pull requests and getting your code reviewed before it goes into mainline. So, Black, ISort, this kind of list right here, Black, ISort, Flakate are just ways to format your code in such a way that it's, basically done by robots, and, you kind of rule out a whole class of arguments the team can have. But kind of more importantly, there's this thing MyPy here. And that's also a root of kind of Pydantic and what you'll see kind of we can do with FastAPI. So MyPy is a type checker. So if you're familiar with like writing C or Java or some other type language, right, you define a variable to be an int, and the system can make a lot of assumptions about that because it knows it's an int. But more importantly, if you try to use an int as a string, your code's going to complain, right? So Python turns that into a nasty runtime error. That means some client's going to make a request and the server is probably going to blow up and return this garbage or fall over completely. Unless you take precautions, probably at the serialization layer to use your data the way you've defined it. So MyPy, as we'll see, is a tool to help that happen in the Python world, essentially add typing to a non-typed world. And CodeCov is just a coverage tool to set alerts when somebody pushes code that drops code coverage. Uninteresting to talk about. Yes, just so while we're going over the stack, some other things in the stack that I found useful that you're probably familiar with: SQL Alchemy and Alembic. This stuff's not what we're talking about. Let's go with this. So yeah, what is FastAPI? Like a little intro on FastAPI. So it's a really fast and lightweight API server. If you've been around Python long enough, you've probably seen all types of micro frameworks on one end, and on the other end, there's Django. So on the kind of micro framework side, there's even Falcon and I think Pyramid, and forgive me, but there's some even lower than that are essentially just, they serve up byte streams. Maybe that byte stream is JSON, maybe it's some binary protocol that forgoes JSON completely, but they don't do anything. You bolt on everything. You're responsible to bring the things to the table to make an API, but it's like really good for maybe you're writing for an embedded environment. So that's one end. And on the other end of that is Django, right? Django is a very popular framework in Python, and I highly recommend it if you're looking to get use Python in the web development world. It's a really nice way to get up and moving really quickly. Everything's tightly integrated. You don't have a lot of choice in database. How you talk to the database, what databases you can use, serialization, kind of the whole kitchen sink of the ecosystem is kind of really tightly integrated with each other, and it's hard to swap out some parts. But what you get is a system that does a ton for you because, right, they know how everything works together because everything works together unconditionally. There's not this abstraction layer of, hey, you can bring this database to the layer to the table and this ORM to the table and glue them kind of loosely together. And that's really cool, but it's slow. You pay for that. And Django is no fast API by any means. So that instantly ruled out Django for my requirement. And that's why I think fast API kind of sits more towards the micro end, but not quite the end where you have to do everything yourself. So that kind of leads me to the next line. So FastAPI is based on Starlet. So Starlet is somewhat of a micro framework, a little step above that. But it forgoes the serialization layer, some of the nicer stuff you get with APIs that kind of you take for granted maybe until you use a micro framework. But Starlet's kind of the micro version of FastAPI, you could say. But FastAPI is essentially on top of Starlet. So it uses a lot of Starlet stuff internally, but it will wrap like a data serialization layer around the controller, essentially what you expose to like an endpoint, like /animals or something. It just adds features to it. So FastAPI will never be faster than Starlet, but it's actually pretty close. And Starlet's a good choice if you don't need the stuff that FastAPI offers. Can't recommend Starlet enough. I actually use that on some Raspberry Pi servers that I make. And kind of a theme you'll see with FastAPI, and I think just the way modern Python is going, Python itself is, it's a pretty slow language. It's a dynamic language. It's very, very flexible. It doesn't have a lot of the kind of development weight that a lot of compiled languages have, but it's not fast, and that's obviously a problem. So how do you make Python fast other than just like making the core, the Python language faster? You can, take the choice of, optimizing your code in different ways, or you can kind of rip stuff out behind the scenes and make it act like the Python code you're used to. And that's kind of what some of these libraries do. So they take something in Python, so a library per se, and they will rewrite it in C. And ultimately Python is implemented in C, like the actual compiled language. So you can actually hook these C libraries in to Python, and there's like this kind of layer that bridges Python to C or Python to Rust or Python to Go. You can kind of see where I'm going. There's probably bindings for all the popular languages. So what you do when you do that is you are executing machine code rather than evaluating Python code And if you've ever seen a PYC file, right, that's the bytecode. And that bytecode gets ran on a central VM. There's a lot of abstraction there, a lot of cost and performance, and ultimately it's Python, so it's single threaded. We'll get in a little bit into async IO in a future slide, but long story short, it's slow. So what they're doing is replacing components with C. So this stack actually includes that. UV loop is if you've ever written async IO. So async IO is jumping ahead a bit. It's just a way to write Python so that when it's doing like a network request, it's fetching some data that you don't have to wait for that data to finish to move on to the next line of code. You can that can kind of do its thing on the side and then continue on kind of evaluating code. And then when that request is done, like it continues on what it's doing. But in a sense, you're kind of juggling multiple things at once. It's more hand wavy juggling things at once. It's not actually juggling multiple things at once. Long story there. But UV loop is a way to replace that whole entire kind of mechanism for that loop, event loop of work. So essentially, it just rewrites it in C. And then it's starting to use operating system level primitives to schedule those operations and stuff. And it's out of Python into the machine way faster. Rinse and repeat that with a few popular things. I bring up UVicorn because that's kind of what I use. So GUnicorn is just, been around a while. GUnicorn, WSGI, they're just layers between your Python app and your web server. There's a layer there called ASGI or WSGI. It's just so you can write your code and run any server. It's like a standard spec. But GUnicorn is one of those layers that essentially help expose your Python API to a little bit more performant way to talk over HTTP. And you can actually replace GUnicorn mechanics again with C with this project called UVicorn. And kind of rinse and repeat that with all types of components. So, you're obviously doing a lot of string encoding, decoding, talking REST, right? You're taking essentially binary and converting it to strings, right? That you see in your browser and in your Postman, JSON. So that's obviously a great thing to have in C because that's very IO intensive. And rinse and repeat with a ton of stuff. So now they have DNS libraries that are written in C. Just like, rinse and repeat kind of all the slow things. Let's write it in C. And if you're familiar with Rust and kind of some of these new languages, they're actually doing that with a lot of these really fast, safe languages. And not C, because C is a little bit old school these days. And any API, it should be transparent. And I have some good examples of this, but going back to the Django versus Falcon, that doesn't do much for you, and Django does everything for you. I think it's a good thing to have that paradigm where you still do a little bit of work and you get a lot of value from whatever you're using, and FastAPI kind of gives that to you. And it stays out of your way. You write code and it handles kind of the API stuff. Dependency injection, I'll just show you what this is. It's a little hard to put a face to that without some history. I won't. This is just async IO. We talked about it. There's not really much to say about it other than using FastAPI. You have a choice. You can use async IO or not. So what does that mean? I can have a function to say it needs to fetch data from websites 1, 2, and 3. I can run that in async and get the performance benefit there of making those 3 requests kind of concurrently. So theoretically, it's faster. But what you end up with is a more complex Python program. So writing async IO is not completely free in the sense that you have to make certain stipulations in writing the code. It gets a little bit messier with the async kind of workflows of things. And then your kind of program starts to spider into what's called AOI madness. So like generally Python is blocking. So again, going back to like how we had all different parts of the Python stack written in C, as soon as you like hit like something in your request stack that isn't written in C, that's written in Python, you're back to good old school blocking code, and your whole app's going to block on that little bit of code. So what you end up doing is you start replacing all these things with async IO, and then you can wind up with a mess if you're not careful. So FastAPI lets you write async IO if it's your choice, but you don't have to. You can write it with none. And it's as literally as simple as, just got to show you this example. So this is a handler, and we'll get into the guts of this. So I'm just bringing a point home. So this is a handler just to serve, just a request for slash. It just hard codes hello world back. So this is the synchronous version, and this is the async version. And that's it. That's all you have to do. I actually write a lot of code async. I like async IO. I've done it enough to know kind of what to avoid and where it's not good, but I think it's quite fun. So it's nice to have the option. And that's really good when you're like building data stuff. Like if you're building a lot of data APIs, async IO can be a good thing. And some APIs either are 100% async IO or 100% not. I think it's a less popular thing that they're either or. And kind of more importantly, and this is like, we're not going to go over like all the components of FastAPI and why it's an API. Like there's a standard set of tools, kind of any API worth of salt will have. So we're going to go over like why FastAPI is special and like why I think it has something valuable to bring to the table. And this is kind of one of the icebergs. This is a big deal to me, at least, and kind of a reason why I went with it. So FastAPI, Pydantic are actually from, I think, the same author, and he has some other tooling. And they typically use what's called annotations. So going back to like, okay, Python is like this generic language. Let's just pull up a console here. Like I just say, name equals Lyle, right? Or I could say name equals 1. It doesn't matter. But maybe I want to define what name is. Is it, we'll say, it should be a string. And maybe you want to say, hey, it's a string that should be, greater than 1 character length. And maybe it should be less than 100, et cetera, et cetera, et cetera. So you're starting to whittle down how they can use name. And what you end up with is, for one, you have a safer program if at least if your program follows what you desire it to be used like. But you also get like, if there was some way to do this, the people reading your code will understand your intention. Like, what's my intention here? Okay, if I see this, maybe I understand, maybe I don't. But going back to like, I want a name of a certain length and all that stuff, it's hard to tell that. And then you might see one definition in one place and serialization in another, and like validation in another, and like you start to lose the meaning of like parts of your program. And this is kind of what annotations brings to the table. This is essentially adding a typing layer to Python. So I'll give some examples. I'll start off with the active one here. This is kind of the bare bones guy. I can actually, why don't I, just that's big. I don't know how to do that. Okay, so you can have like so active full equals true. So this means that active is a Boolean type, right? And it equals true. Okay, so that's not interesting. But you can say, this implies that it's a required field, and you can say, hey, this is an optional field. It's not required. There's actually a bug here. There should be, for this kids only line, there should be equals false or something. It's a keyword argument. But long story short, like you're conveying to somebody reading your code that, hey, it's optional. And kind of rinsing, like get a little fancier. So for people, so you can take this a few different kind of ways. You can say, hey, people is a list. Oh, is a list, right? And that just means, hey, it's a list of stuff, okay? But maybe you want to say, hey, it's a list of, person. And then that's like, that's a pretty big step up, right? That's saying, okay, it's a list, but it's a list of only this type of thing. And then, you can even take that further with that here. I'll have cool examples right here. So this is essentially taking, or saying people is a list of people, and people is an object. And then, you can kind of sky's the limit. You can like mix and match these things. So say you have a tuple, which is one of these things. So my tuple equals, this is a tuple. But you want to say, hey, it's a dict where the keys are strings and the values can be anything. So that would kind of be this. Oops. Let's say key, that's a string, and it doesn't matter what the values are, but this fits, and not making any sense here. This fits too, technically. It's still a tuple of dictionaries where the key is a string and the value is any, literally. That's where typing blurs the lines, right? Like this wouldn't be in a lot of compiled languages. Python's still being dynamic and kind of super flexible. Sometimes that's good, sometimes that's bad. So sometimes you want to say, hey, this thing can be a variety of things, because hey, we're writing Python after all. Nobody's going to tell us what to do. So you can say something is a union. So it can be a string or an int or bool. So like the next question people often ask, like, and feel free to ask me questions during any of this, make a noise, I'll stop, ask questions. I'll provide better examples here in a bit relating to FastAPI. I forget what I was getting at. Oh yeah, so if you're coming from a compiled language, you'll say, hey, okay, is there a compiler? Like, how are these kind of types enforced within our program? It's kind of optional. It's kind of hand wavy, right? It's Python. It's more of an opt-in thing. So you can do these things exactly how I have typed them and completely violate every data type. I'll set a bool here, string here. The system is not going to throw an error. It's not going to complain very much. Just vanilla Python doesn't matter. It's syntactic sugar to some degree. But going back to MyPy, that tool where you can essentially check that your code is kind of using these things appropriately, like essentially what it does is it looks at these, says, hey, this people is a list of people, and I'm going to try to statically see how you're using it throughout the code. Hey, you did a dot replace on people. That's a string operation. It'll warn you that you're trying to do maybe a string operation on data type that doesn't support it. And it's essentially an opt-in linter, so a program that you can run against your code to just kind of flag warnings for you, but it's completely opt-in. And very useful in the scope of Pydantic, which is what we're building up to here. In FastAPI, just kind of some highlight reel stuff. Given this, right, you can inform the code base of your intentions of how you want to use this data type and how you kind of planned to use that data type. So what ends up happening is the code can do a lot more for you. So as we'll see, it can be used in other contexts, like a data serializer. Maybe you can use annotations instead of a bunch of custom functions as part of that library that relearn, and who knows how they're implemented. And you can start to do cool things like docs, right? Like if you're, wrote an API like even 5 years ago, 10 years ago, you had to produce these Swagger docs and like put doc strings everywhere and do all this madness and literally, hand code your response types, your response codes. Like it's very laborious to essentially produce documentation for your API. But since you're going back to here and you're telling it exactly like all this stuff about your data, this can carry over to the payloads you're sending to your API in JSON. And what you end up doing is you're creating a system that knows a lot about itself, so it can create incredible docs for free, essentially, or with very little effort. If you're used to open APIs, so like open API is essentially the map of your whole API and all the endpoints, possibly even like the different values for the fields. So essentially, a front end person can take it and easily build a front end and kind of know about your API without reading a bunch of docs. But there's a lot of tools that they can use to create a mock server. You can create collections in Postman. So Postman is just a way to, it's a GUI, a graphical interface for kind of browsing API. You can just import this open API into Postman, and it'll kind of populate with all the endpoints without you inserting them manually. A lot of good will come of this, and front end people will love you for it. And as we'll see, it's kind of for free. And Redocs, and I'll show you that. It's just a new age Swagger docs. So if you're used to Swagger docs, it was open API these days. But long story short, they're kind of crafty, little ugly. They kind of look like this. Oop, not like that. Kind of look like this, and that's actually prettier than it used to be. But once you start filling it up with a lot of words, it just formats it awfully. And we'll kind of get into like making this a little bit cooler. I will show you what I'm talking about. So this is kind of the new age, same thing. It's all working on the open API spec. It's just interpretations of that open API spec, and you get this pretty UI. And I've done nothing to get all this stuff. Okay, so going back to presentation, nothing to really say there. It's just, the code knows more about itself, so it can do more things. So FastAPI. So in all APIs, there's what's called a controller. There's typically like a controller, like a data layer, and a database layer. So controller kind of sits at the top. So when I send in, if I just go here, right, this is hitting really the slash route. And that is mapping to what's called a controller. And in this case, it's this guy. So it's saying, when I get this in the URL, return this response. I'm just saying hello world in a JSON dictionary, nothing fancy. But a controller is the part that essentially takes in a request if you're creating something, and then hopefully validates it. Maybe it creates a database object and then returns some kind of response correlating to what you just did. There are parts of that controller that, say that you want to, I'm in the browser here. Say you want to, do URL arguments, limit, classic pagination, we'll say limit 10, page equals 30. So those are URL parameters. You typically use them for filtering. Maybe you want to create an object. So this is like, on the animals endpoint, I want to create an animal with a name, has this many legs, it's this type of group. You're going to have to define what this endpoint takes in as data, what it means. So like maybe what are the valid values, what are the constraints? Maybe I want to, if you send me a field that I don't like, I want to raise an error. But essentially you want to define how you accept input. And then, this is the output side. Okay, I've created this in our database. I'm going to spit out something in classic REST fashion. It's like the essential resource of what you created. The same thing you created, but with database stuff like an ID, created, updated, blah, blah, blah. So nothing too fun there. But how do you do that in FastAPI? And in a way that, as I said, saves you time and keeps you safe. So this is kind of the kitchen sink. So don't be too scared if this is all familiar or not familiar to you. So this is that controller, just with a bunch of gobbledygook to kind of show off some features. I probably should change this, but I stole this one from work. I did this presentation for work. Spoiler alert. This is the endpoint, business units, and the response will contain a list of business units, right? Because I'm saying / business units, like give me all the business units. And I'm gonna say, hey, it responds with a 200. So HTTP status code that just means, hey, everything went okay. The browser and people that write JavaScript and clients to talk to REST APIs, they kind of know what that thing means. And you have, I'm skipping ahead. So that's the URL. So this is response serializer. Okay, like going back to eventually getting this. How do I get from Python, like the data that I return, maybe it's from a database, to something that looks like this that you know, a REST API can, or a REST client can then use. So it's kind of this. So my responsibility here is to return Python. So in this case, I'm getting a bunch of business units from the database, like database models. I've done nothing for Pydantic at this point. I've done nothing for FastAPI. You know, I'm purely talking my data, and it doesn't care about my data. But I have told it I'm going to return a list of those things. And what we'll see in a minute once we get to Pydantic is how we can take a Python thing and turn it into a JSON thing. So just know for now, we'll return database objects, and it kind of transparently, magically converts it to JSON via this definition. And then, you know, we have limit and offset here. So these are how you do URL parameters in FastAPI. Like this is, you know, again, the controller. So I'm saying, hey, limit is an integer and offset is an optional integer, but defaulted to 50. So that's going back to these little things, right? So limit 10, you know, blah, blah, blah. And then, you know, that's essentially that. But in some, the reason why I even pointed out is in some frameworks and a lot of API frameworks, like parsing URL parameters tends to be something outside of like core serialization. So usually you have to write manual code, and usually like it comes in as like a raw dictionary, and you're kind of doing gobbledygook to like get stuff and parse it and all this stuff. It can get messy, and you get this for free through here. And I'll show you kind of how validation ends up. So like this actually validates your request that you send in just on this little bit of information. I can actually go ahead and show you that here. So I've set up a page with just limit and offset here. You know, limit is an integer, page is an optional int, and we'll default to 10. But we're going to, you know, going back to this, like we've said, hey, limit is not optional, right? I said it's optional, so it's required. And then page is optional and make it an int. So if I just send in no URL parameters here, this is Pydantic. I'm kind of jumping ahead. This is Pydantic kind of output, essentially telling me that, hey, you know, you said limit is required, but you didn't send it to me. So this is the validation message. You know, I don't want to spoil that too much, but you can then satisfy it. You know, limit equals 1, and then all is good in the world. And yeah, it accepts page, whatever, as it states, it's completely optional. So for good measure. Yeah. So, and going back to the docs, might as well bring it home with the docs. I'll spare you the OpenAPI spec, but if I refresh this, you actually see the, so I've done nothing here. This is purely working off the definitions that we just discussed. So it says, hey, on this page foo endpoint, it you know, sets the integer. Hey, look, this is exactly what we talked about. It's required. These fields are actually, you can actually hook it up to make live requests and fill it in and use this try it out button, but we're not going to do that. And remember, we defined our, where we're at here. We defined our status code to be 200. Hey, that's there too, right? We said, hey, 200, 422 is kind of this implicit thing that works itself in there because that's the default kind of validation error. And as an API maintainer, maybe I have several things here. They're easy enough to enumerate as well, but we won't go into that. And you can enumerate examples, all types of stuff to really like, you know, going back to do a lot with a little, like you can define some like silly examples in some doc strings, and it uses them to hook up live requests to express to your user like how you can use the, you know, your API. And what else? Earlier I said, you know, there's this concept of dependency injection. So it's kind of an advanced topic, but what it really gives you is like a way to, for one, chain conditions together on a request and transparently kind of do almost bootstrapping code for a request. And that just sounds kind of hand wavy and probably complex. So I'll give you an example. So JWT creds. So this is like a thing very unique to FastAPI. This depends on. So this is saying this request depends on this function, which actually intercepts the request object. And it basically needs to pass to keep on going. So this is perfect for something like an authorization scheme. And this is kind of how you do it. It's pretty complex to talk about, but just know this is how you do it. But if you wanted to chain multiple kind of things, so like say you wanted to make sure that they, I don't know, exist in 3 different systems before you carry out this request, you can kind of use these things for it. Or in this case, it's a little bit easier to understand, this db equals session depends get db. So what this means is each time somebody hits this controller, give them a handle to the database, and then you can pass it into the data layer to kind of do CRUD operations. Maybe you're creating an entity. In this case, you're grabbing all the business unit entities out of the database. But at the end of the day, it's good to have a database handle kind of at the top level. So in your controller, so it's passed through. So your code isn't like constantly checking out database connections and kind of blowing up your database. But when I first saw this, I was like, oh, that's bad, because hey, this is going to check out a database session for every request. There's some stuff that are easily like 10,000 requests a second. Pretty heavily used stuff. That'll instantly top over my database. But what it's really doing is it's being lazy. So it's probably a topic for another talk. I'll show you here. So this is all this function does, right? It's getting a database session, but it's yielding it. So no work is actually done here until I iterate over that little generator. So that's a fancy way of saying that this is lazy. So it doesn't actually check out a database. So when I'm in here and I go to get business units and I want to use that database connection, I'll do like a next on it or something and resolve that iterator to actually get the database. But what's nice about this pattern is you have the database connection at the kind of highest level, the controller level, that you can pass all throughout your app, which is really good for saying like, hey, I want to build a transaction, right? I want to build a database transaction of all these things. And when that last thing goes wrong, I'm like, roll it back, right? If you're checking out database connections in the middle of your code everywhere, what tends to happen is you're building a bunch of microtransactions and you lose that all or nothing approach of a database transaction. Again, I won't go too much into it. There's some reasonable docs on it, but it's a pretty unique thing to FastAPI and interesting to learn about. And I didn't follow all the headers that I did. Did I miss anything? Yeah, rather write some code. Oh yeah, so this is a good example of a post, right? So what we talked about is kind of the basic like get data and serialize it to JSON. Serialize database models to Python, or sorry, JSON. The kind of interesting part of all this is this. So I've said, hey, this is a post endpoint. That means you're going to send me JSON. So this type of thing, right? You're going to send me what an animal is. I'm going to maybe create it in a database or something. And I want to make sure that the data you send me follows the kind of stuff that I or the format that I expect and follow the constraints that I laid out. So that's this action right here. So I'm saying payload is of type create business unit schema. And that's something we haven't discussed yet, and that's coming up next, but this is a Pydantic thing. So long story short, that code that somebody sent as part of their JSON payload is going to be essentially transparently thrown at the serializer. And going back to those the feedback error messages that we got when we were doing invalid offset and pagination, this rinse and repeats to your whole payload. And that's kind of confusing without actually showing you, so I'll hold off on talking about that. So, enter Pydantic. FastAPI is very much about the layer to essentially intercept JSON, do something with it, Pydantic probably, and then respond with it So Pydantic is very much that, hey, let's define your data, kind of like the database model. And then we're going to serialize your data. And if it doesn't fit what you expect, I'm going to complain about it in a way that's very easy to parse. A little bit noisy, it was a little bit obnoxious when I first started using it. I like really clean, simple error messages and interfaces. And as you saw in this kind of paradigm, let's go back to this. We're going to create an invalid condition. Right, this is just one error message. This is kind of obnoxious, but when you start writing code against it, it makes a ton of sense. Yeah, I'll skip discussing it further. So Pydantic, going back to Django or Falcon, does it do everything for you, or does it do nothing for you? Pydantic kind of takes the approach of use whatever database you want. You don't even have to use a database. You can use Pydantic on just dictionaries of data. So if you're doing analytics pipeline work where you're really just kind of data munging stuff, Pydantic is great. You don't need FastAPI. Doesn't depend on FastAPI. Pydantic is just a really great thing for that. And it's powered by annotation. So the things that we showed you and that kind of comes with an asterisk. Once you get fancy, you start using Pydantic stuff, but at the end of the day, everything's attempting to be annotation powered. So you don't have to learn all this new frameworky stuff. You're essentially leaning on the standard library to do stuff libraries spend thousands of lines of code to attempt to do, which is really nice, right? Getting back to like moving fast and safe, like you're writing code that's well tested, right? It's part of the standard library, not part of some project, right? That's going to break next Python version. Like I said, it works on Dixer instances. And what I mean by that is instances are just like really anything with an attribute. Dictionaries is one behavior of Pydantic, and the instances is another. And that allows you to essentially take a database object in Python. So like that object.name would be the name, and kind of use it that way. And I'll show you examples to kind of put a face on that. Standalone FastAPI is really good for parsing nested data structures. Just how we can mix annotations like willy-nilly. Like we could have a tuple of a dict containing only dictionaries of tuples of the list goes on. You can do that with your serialization layer. Poor users, feel sorry for them on your API, but sometimes you got to do what you got to do, and businesses are businesses, and sometimes you have to put up with those really noisy payloads. And Pydantic just solves it really elegantly. So let's apply some of those annotations to a Pydantic model, and then we'll get into how to use that model. So this is a person, 645. So this is a person model, right? This is like, hey, I know Python annotations. This is kind of how I would sit down and do it. This is kind of how I did it. It's probably on the first page of their docs. But going back to constraints, okay, it's a string, but I haven't defined, hey, it must be one character. Hey, it has to be under 100 characters, right? I don't want somebody uploading encyclopedia for the name field and blow up my database. And I have hobbies. Hobbies is a list of stuff, but it doesn't say what kind of stuff. So then you start to get a little bit more specific, right? So hobbies, we'll say it's a list of strings. Name doesn't get any more fancier. And then you say, hey, I want to add those constraints we were talking about of length and this, that, and the other thing. So you start using these things called constring. There's essentially con, it stands for constraint. This is a Pydantic thing. So constring, conlist, there's condict. There's a few other ones, I think. They're all the same kind of thing. They're essentially a replacement for this basic annotation and providing constraints, right? This is a string field, so min length, max length. You can strip white space. There's a few little things in here. It's pretty simple. There's not a lot of options, but you can actually, create your own and get pretty fancy with it, which is great in a business context. And you can even say, hey, this is a list that must contain 1 to 5 things, and it must be they each must have a length of 2 to a length of 100. So again, you go back to nesting. Nesting's arbitrary, so you can nest as deeply as you want and get as complicated as you want. It'll absolutely let you. But what you end up doing is this is like a weird thing when it comes to Python. So you're saying this is of type this, but this is a function, right? Where this is Python. This is a runtime thing. It's a little weird. Well, MyPy hates it. We can actually, yeah, I could do a whole talk on probably MyPy and all that stuff, but we're gonna show you a sample. I have them curated already. So serializers v2 is, I think the exacts. So it's essentially a model. I created an animal class. It's the same thing though. So it's using those things we just talked about, constring, conants. And we're gonna depend on MyPy to kind of double check after us and make sure we're using annotations correctly. But you get this nasty little error message. Essentially what it's complaining about is, hey, I don't understand this as a type and I don't know what to do. I'm gonna yell at you. And this thing is actually, this lint error is actually very hard to isolate and get rid of in a spotty way. So I actually had to solve it. And I'm glad I did because it's quite easy. What you end up doing is there's actually base classes for all these things, constring, conlist, right, on and on and on. You can see it here. This is just imported from Pydantic. Should have put the imports here. But all you're doing is busting out those functions into class attributes. And it says the exact same thing. So then you end up with this. You say person, this is the create schema. So now it's a name of type, at least one char 100, silly name. And then hobbies, right? At least 2 to 5 items of at least one char 100 string fields. So this is absolutely MyPy, happy. MyPy understands this and all is good in the world. And there's really nothing more to say here other than, you can start with this and that's fine, but ultimately you'll want this. And this is the kind of right way to do it if you want it to be supported well by tooling. Okay, so, on Pydantic, they're strict and non-strict. So it's actually, I don't know if I really like it from a standpoint. I deal a lot with data, which means that I like data to be consistent. But sometimes when you're just building like an API around business entities, you don't have to be so strict. So what that means is like strictness is, I've defined my animal serializer. And we'll say, in legs is an integer, right? Is base class constraint, constraint int, greater than 0, less than 10, it's multiple of 2, we'll get a little fancy. But this is an integer, right? But I've made it a string here, but it's a string integer, and hey, it works. And hey, it's actually an int. So what it's doing there is, by default, they are not strict, and they will happily cast if it's castable. So one, maybe yes, I forget if yes is included in that, but those cast to true, vice versa for false. This casts to integer just fine. I think for bulls, you can even do like true, and that casts to, if you were to do this. So I typically turn strict, create a base class, and kind of create all my stuff as strict equals true. So that's one of these arguments. That's all it takes to do away with that behavior. And then what happens is, hey, let's do like demo. We'll say this is the field we're just doing. This, see what happens. So this is just the server. I didn't bore you all with those details. All right, so yeah, so there. Now it's in strict mode, the same thing that, well, I changed the data, but it would have happened anyway. So this is essentially what happened. So yeah, it's just being more specific and opinionated about your data, which you should be. And very specific feedback. Going back to like this type of thing, this one's kind of not very deep, right? It's on the main line. But when you start getting like really nested data, like people like, rinse and repeat of stuff, like get real deep and buried, something like a JIRA output. where it's just gigantic. This thing comes really helpful. I unfortunately don't have an array field here, but like if you had an array field where you said, hey, this is a tuple of this fancy type of object, and one of those like 100 items is wrong, it'll tell you the index of the array item that's wrong. And if it's nested, it'll tell you exactly how to get there. But it looks at everything very uniquely and individually, so you get just really great error messages. And going back to like, I used to write stuff very simply, and those things I kind of just avoided. Like, what array index is the problem? I might just tell you, hey, there's a problem. But this will, for free, tell you which array item is the problem, or which dictionary key is the problem, and why it's wrong. And then it gives you like these nice things, type error integer. This is essentially what you'd map a like front end kind of either error message or like kind of widget to display. The message is probably what you bubble up to the user. And this says body here because it was in the payload body. When earlier when we were in the URLs, it told you it was in the query string. So like it gives you a ton of information. And I even like, when I started this, I overwrote all this stuff and kind of trimmed it down. And I've since taken all that out, and I definitely use the verbose message, and I've kind of learned to like them. And yeah, we already kind of showed doc generation. Doc generation is just really awesome. Like this is the redoc stuff. So this is like I said, the new age stuff. I just created a really complex version of this at work for an API with examples, and I had code samples here for like C and I'm sorry, not C. Why would I do that? JSON and Python and curl. This and the other thing, and it was pretty cool. The only bad thing about this is called Redoc. So this is actually the product name. They have a non-open source version, which has a lot more bells and whistles, but you can only get the try it now button on the paid version. So like I can connect servers and everything here to attempt to do live requests. It has everything it needs, but I can't actually hit make a live request. It's a paid only feature, and it's really expensive for a team. Kind of disappointing, but in general, this is amazing. All right, it looks great. Like all these things expand. Like I haven't configured some of this, but this would show like the models of the response types. With a little bit of effort, like this gives you full examples. So as a new user, they can see how to use your API. Like these are all at the top level root, but if you actually, let's do that. If you just tag these things, so there's all types of stuff supported. In these arguments, so we're just going to do this real quick. This. Created this whole thing for this talk and didn't use that. Okay, so watch these things right here. So these are just, if you had a bunch of endpoints, this would be kind of gross. Sorry, my server takes a bit to restart. Put them all in here, and it's that easy. And you can add top level stuff for like, more wordy docs and keep this more engineering focused. With doc strings, you can. So this is a good example of like, I've spent so many hours of my life transcribing these things to tables and API docs, and then only to get out of date when somebody's not paying attention. So this keeps it one-to-one with the code. I've not written any of this. It's purely looking at the Pydantic models and generating this. So I get all this for free. And then you can actually do, your own, say you had custom error messages, custom whatever, hey, this payload has been dispatched to this job server, blah, blah, blah. You can document all these, and they make this little box and they expand to the payload that you define. But rinse and repeat, going back to doing a lot with a little, this ticks that box for sure. What else is there? Yeah, so the thing about Pydantics is really cool. Like we went back and said it was DB agnostic. So okay, I used it with SQL Alchemy, Postgres. Nothing really interesting there, but since it's not ORM specific, it's more just, again, talking Python objects with attributes on them. It doesn't care what kind of model they are, where they came from, as long as like you've said, let's see, I can talk about this a little better. So as long as you've said, take this for example. So as long as you like give me an object here with a name attribute, I don't care. Like I will resolve it to a value and validate it accordingly. So in that case, like if I just like pluck a database object from the database and use SQL Alchemy, which is like a way to hydrate SQL data to a Python data structure, that all kind of works naturally. Or if you just had like a class, my animal, actually we can do that. Well, I'll finish the thought. Let's say you had class, my animal, and then, yeah, name, that. I could absolutely say my animal, and then take this serializer and then do this, my animal. And go, and this will actually blow up because it doesn't have the other fields that I said, hey, these are needed. But this is the concept of, they call it ORM mode. So I have to tell it, hey, I'm not just going to give you a dictionary. I'm going to give you a model with attributes. So you just have to give it this little guy, and then it kind of works on attributes. And did I mention it here? Yeah. So some other things about like serialization. It can get kind of fancier too. Like there's tons of arguments that you can be using here. But like say you have a project that maybe has an old internal model and you want to clean it up and write an API around it. So essentially your database fields are ugly and you'd hate to expose those to the world. You can say like name equals string. We'll see this. Okay. You can say this is just the default value. That's not interesting, but you can say alias mine. And actually, I think it's backwards. I think it's name. No, I think it's right. So that essentially means like the incoming. Maybe I have this backwards. We can actually try it if there's time. But this essentially means like going back to ORM mode. So my model's name is dot name, but I want to expose it to the API as my this version of my name. So this field, say this made sense. Let me just. Oh, yeah. Yeah. So these guys are. So you can essentially talk at the data layer with these fields and then expose these fields. And like I said, I think I had that backwards. And so essentially, like just because your model looks a certain way doesn't mean your API has to be one-to-one with it. There's flexibility there. And like that is, I think, the crux of what I wanted to explain, and we can hack on it if y'all want. It's 7 o'clock. But I guess what could be better. So this was like a really quick survey of like why I think it's special. It has middleware, it has fancier stuff that most APIs support. You can have a default response. Say that you for all your list endpoints, you do a results main key and then have your data under that results key, and you have pagination like as fields. As fields in here, like you have some fancy shape here. You can define these things, just like in the API, like a default response format, and kind of sky's the limit. And you can write middleware so that you can, you have Sentry that you can do authentication with. Sky's the limit. It has all those things. But what it doesn't have, and like what could really be better, is like going back to like that micro Python framework vibe of like here's the tools, and it's up to you to put it together. Minus FastAPI and Pydantic, those kind of go hand in hand, but like database layer and how do you expose the database to the API layer? Well, some of that's like bring your own, right? It's like you wired up, like in this case, like I have my controllers. So the controllers are kind of dumb. It's really just responsible for defining how data comes in and how it goes out. And then there's like a middle layer that the controllers call into. So like to get an animal, right, it calls into this kind of data layer to resolve the payload to a database entity. And then like the database looks like a certain way, like this, right? It has a name, legs. So you kind of repeat the stuff like throughout the stack. And that's what a lot of stuff like Django, for example, has for free. You essentially define a model, and you can say, hey, create this serializer from this model, and like it essentially reads how you've configured it at the database level to come up with those constraints for that serialization layer. But Pydantic is not database, doesn't care about the database, so it doesn't have that tight integration. So what you end up doing is like, this is how I would define my database model, and then this is how I've defined my serializer, right? It's basically the same thing, just said differently. And that's kind of annoying because also from a validation standpoint, right? You want to be good and write all your validation here. But then, I'm again paranoid about data consistency. So like say we have a constraint on name that it must look a certain way, or we'll say a regex. I can absolutely actually define a regex here on the validation. But say I'm writing a script or a bug happens and some data that gets by to my database that doesn't meet that criteria. I have a problem with that. So sometimes, if it's mostly trivial, I wouldn't say I would do it if it's like super complex, but I like to duplicate some of my validations at the database level because like, this is SQL Alchemy. You can say like validate, the name field, some certain way, and then write a function to validate it, like that it meets some regex, blah, blah, blah. But then you end up with like basically duplicate efforts on validation through paranoia, and that's kind of annoying. So that's where, I think it was even discussed at the beginning of this, like, kind of like Flask, right? Sometimes you compose it in such a way where it's just awkward and doesn't fit together tightly. Well, this is kind of a symptom of that. But it's really young too. So FastAPI is a pretty new kid on the block. If you've ever used Flask, there's Flask SQL Alchemy. So that essentially bridges that gap of database model to API and tightly integrates it. FastAPI just doesn't have those layers yet. It doesn't have a lot of layers. Like I had to write some OAuth stuff like 6 months, a year ago, and I had to write it all by hand. For one, I needed to anyway, but like, it's not like Django where you have 10 years of tooling, maybe it doesn't work now, but like you have something to go off of. And generally like Django, like you find what you need within like an hour. FastAPI is not like that. It's gotten a lot better and it has a ton of momentum. It's quite popular in the community for all these reasons that I've talked about. It's just modern. It's like, it's the new age Flask, and that might hurt people's feelings, but I really think it's going to be. It's like that, classic thing where they just take a technology every like 5 years, whatever, and just like think about it with all the problems of the last 5 or 10 years kind of solved or attempted to be solved. And it's just like, this is that iteration, right? Like Rust is that iteration, and systems programming, like this is like, everything's coming full circle to that end too. Like everybody was like, oh, NoSQL is awesome. And then, hey, this is too Wild Westy, we need schemas again. And now people are adding schemas on top of NoSQL. And this is very much the same way. Like you saw with JavaScript, right? JavaScript's super Wild Westy. They added TypeScript. And that is what it is, but it's a nice attempt at the same thing that kind of annotations are solving, and kind of TypeScript kind of follows the same thing. It's like systems know more about your data, so it can therefore do more for you. And you're just seeing that manifest itself in Python. It's like all the languages are kind of converging to this thing that works out. Nothing really to go here. I mean, I guess it's worth pointing out, FastAPI can run in like AWS Lambda server environments. I use it quite a bit in Lambda on personal projects because I can't afford full EC2 instances running 24/7. But man gun is like a project. So there's kind of like a layer that you need to have to bridge the gap of how Lambda and API gateway talks to a Lambda code, and like how do you serialize that to the request that it expects. Man gun is that option for AWS Lambda, so it is possible with just it's like one line of code that you wrap your API with. Yeah, and FastAPI has incredible docs, and that's what I really respect them for, and that's where I kind of knew I was in the right place when I started this whole thing. I mean, their docs are like beautiful. They're annotated line by line. Like I said, it can get fancy. Well, this is the fanciness. I have some fanciness brewing and some PRs that I hope will help things a little bit too. But it's getting better all the time. And Pydantic, like I said, it's getting used in and outside APIs. A lot of data people are starting to pick it up. It's getting a lot of arguments, like that whole alias thing, like that's just like scratching the surface. There's tons of really cool arguments that I discover along the way. And I don't really have anything else to add and blabber on about. Does anybody have any like questions or comments or?
I've been watching the chat for you, Lyle, and there hasn't been any questions that have come in yet. But does anyone that's here have any questions about FastAPI? Or no, there were a lot of other libraries that were name dropped throughout. Some of them less familiar than others that people maybe have questions on.
Hey Lyle, thanks for the talk.
Hey.
So, do you ever see a reason we should use Flask if we start a new project?
I mean, I would say if you have like familiarity, like writing code is about just like delivering value, like at the end of the day, especially when you're in a corporate environment. So if like your team's familiar with Flask, which a lot of people are, and they can hit the ground running, yeah, like use it. And there's tools like Marshmallow, and you can actually use Pydantic within FastAPI. Flask it's not too opinionated on the serialization layer. So you get the best of both worlds, but I don't hold a strong preference. I'm more in the vein of like get work done and try to have fun doing it. And if Flask is that, then so be it. It's definitely more mature. You're going to hit a lot of roadblocks, like I said. Like I knew the APIs I was building for work are very minimal as far as like it's not running like a whole front end. It's not doing like 30 models, resources worth of work on the endpoints. It's just like a few models. Just has to be really fast and correct. So I kind of knew what I was signing up for. Yeah, like I kind of knew I had like it was the stars aligned, right? I had like this narrow kind of requirement and a good team to do it in, and we weren't under the gun for time, so it just kind of worked out. But it's taken some time to get this far, and even this week I got stuck and then got unstuck. So.
One thing I'd like to add about like the use of Flask or usefulness of Flask is FastAPI is fantastic, and it really encourages you to do some things the right way. Flask doesn't have as many opinions, and you can get something up and running really fast with it. So if you are wanting to go fast and honestly dangerous with that sort of speed as well, you just need to get a web app up or an API up quick and dirty. Flask still has its place. Like I know while I've been playing around with FastAPI here and there, like I still use Flask when I'm just throwing together a POC for something.
Yeah, it's like bash scriptitis, right? Bash scripts always start out so innocently and then they grow into a monster.
Yeah, those POCs always stick around, unfortunately.
Yeah, exactly.
It kind of seems like FastAPI is like sits between Flask, sits between Django. It's a little more opinionated than Flask, but not as batteries included as Django.
Kind of. Yeah, I think that's a fair assumption.
Like to use Django if you're smaller team, need to get something built quicker, and then FastAPI if you're in a larger team starting on a new project.
Yeah, I think my biggest worry with Django is it's just so slow these days. Like even with 3.0, which adds a lot of the async stuff, To get like a few thousand requests per second is a feat.
That's fair.
And there was a Hacker News article just the other day about the trials and tribulations to get to 100 requests per second. And I did that in the IoT space, and we just use Django REST framework, no front end or templates and that. And it was a bear to scale. Like you hear about Instagram and like all these huge companies using it, but I mean they're caching everything. Django just sits kind of as a controller, but like and they're caching everything. So
Yeah, I guess it really depends off what you're building too.
yeah, absolutely. But like you're absolutely right. Like you take a view set and say it's this type of model, and I get like everything I just showed you
Magic.
in
Yeah.
like 10 lines of code. And their serializers are just amazing. It's just really
Yeah.
cool. But in the
Well,
time
cool.
it takes you to configure a new Django project, it takes like I should have done it for this talk, but it takes like less than 20 lines of code to get an API and a route in one file. So,
Nice. Well, cool. Thanks.
yeah,
And there was a question in the chat. Would you please explain more about dependency injections in FastAPI?
sure. Yeah, I can try. So I can look at some code. See where I have it. Oh, I don't have it in here. Let's see. I don't have it in this, and I have it in word code. I can't show the word code. Let's see. So, I mean, I can. I think where I have it. Actually, I think I do have it in public code. Give me 1 second. I'd like to show you because it's a hard concept to talk about. My laptop is very hot right now. Everything's going slow.
Welcome to screen share on Zoom.
Uh, yeah, well, I can't even do it on Google anymore. Whatever they did updated wise, it turns it to toast. Yeah, like my keys are even taking. Let's see. The controller. Sorry, we bounced around a little bit. So slow. The older project, not sure everything is.
What are you gonna show us here?
The some dependency injection, like the actual. This is a little fancier one that that I know less about, but I'm interested to look at it. All right, so I know there's a lot of stuff on the screen here. So this is the how it's used on the controller right here, and then if you go over here, this is like a fancier. The last thing I showed you was the database session where it does a pins get, and this getDB is just a function that yields a database connection, or yeah, eventually yields a database connection when you resolve it. So JWT creds, this is a little bit fancier. This is using a whole callable class. So what this is you can see, so I'm on the left panel here. So this is a class in it, and there's kind of nothing fancy there, but it's callable. So the callable there takes a request, and then you essentially do stuff, and you have a chance to essentially interrupt the request and say, I don't want to proceed. It's almost like an on-the-fly middleware. You can think of it as such, even in this case. But the problem with middleware, like if you were to define this as a middleware, it implicitly will apply to all your endpoints. Then you have to do a big exclude list. So this kind of turns itself on its head, at least with this implementation. I add JWT creds to the endpoints manually. And implicitly for every request, it will call this function, or really this class, call the class, provide it with the request object, the raw request object. And in this case, this is authorization class. So I essentially, this is a kind of implicit, well, it's a lot of implicit code, but this is essentially checking your credentials that the user supplied in the header, right? If they did not supply them, just go ahead and raise an exception, and then this code will not execute. It will bubble up to, as an exception, and you get one of those beautiful error messages that we saw earlier. And that's all it is. And this is kind of rinse and repeat. It's just doing various checks in an attempt to blow up if it doesn't look perfect. So if you're familiar what a middleware is, where every request that you send in essentially has a function called against it, and that's your chance to do whatever you want. It's the same thing. It's just on the fly. Did that help? Let me try to find my chat. There we go. I have a Zoom widget on every monitor. All right. Hey, Mike. Okay. So what else? Cool.
Awesome. Does anyone have any other questions at this time?
Yeah. And I'd like to say, like, the depends on, like, you can build many of these, and you can think of them as going in a line one after the other. So yeah. Anything else?